Welcome back, everybody. In this video, we're continuing with section 2.1. The first thing we're going to do is come up with the equation of a couple of lines. So let's get started. So in this first example, we want to find the equation of a line that has a slope of 2 and it needs to pass through the point -1, 6. We're actually going to do this in two ways, just so that you can decide on a method you like. Either one is actually acceptable. But I like to show both ways because usually people will prefer one method or the other. So let me show the first method. Okay, the first method is to go with the slope-intercept form of a line, which is y equals mx plus b. On this, we're told that the slope needs to be 2, so I'll replace the slope with a 2. That's the m. And then this thing needs to pass through the point -1, 6, so that when x is -1, y will be 6. So I'll replace the y with 6 and the x with -1, and that will give us an equation that we can solve for b. So it turns out that b is 8. So then putting together the pieces, y will be 2x plus 8. Okay, and that does it. That's basically the first way of doing it. We're given a point and a slope, so we substitute the slope and the point into the y equals mx plus b form, and then solve for b, and then assemble the pieces. The second way to do the exact same thing, in which case if you were fine with the first way, you could just skip over this, but a second way to do the exact same thing is to use the so-called point-slope form of a line, which looks like this: y minus y1 equals mx minus x1. And then the m is, just as you would think, the slope, and then the x1, y1 is the point that we are supposed to pass through. So let's just drop in everything we have. So we'll have y minus 6 is equal to 2x minus -1. Got to be careful with those negatives. Okay, and then the next thing to do is we have the equation basically built. We just need to simplify it a little bit. So we'll have y minus 6 is equal to 2x plus 1. We're going to distribute to remove the parentheses, and then finally add the 6 to both sides. Of course, we're going to get the same answer eventually in slope-intercept form. This is a matter of preference. Which one you like, you can use either of these. Either one is okay. Okay, so now we're going to try another example. So in this one, it says find the equation of the line that passes through these 2 points. So what's different on this example versus the one that we just did is that in the one that we just did, we were already told what the slope is. This one, the only thing that we have is what points the line passes through. So our first step will be just to calculate the slope. So that will be step 1, basically. So let's start by getting the slope. Okay, so we have a formula for slope. It's the change in y over the change in x. So let me go 3 minus 1. We're subtracting from right to left. 3 minus 1 divided by 6 minus -4. So that will be 2 over 6 minus -4 is 6 plus 4, which is 10. So we have 2/10, which is 1/5. So that's the slope. So now we're going to finish this. I'm going to do this again in 2 ways, just for illustration purposes. First, the y equals mx plus b way. We know the slope is 1/5. We figured that out. And so all we have to do is drop in an x and a y, and that will help us solve for b. Here we're given 2 points. It's up to us to choose. We could use -4, 1. We could use 6, 3. Either one will give us the same answer. As a point of just being practical, it might be easier on you to choose the 6, 3 just because it doesn't have a minus sign in it. But either one will work. When x is 6, y is 3. Whatever you do, don't take the x from one of them and the y from the other. Don't use -4 for the x and 3 for the y, in other words. Just use the x and y from one point. Okay, so we're solving for b. So 3 is equal to 6/5 plus b. We need to subtract 6/5 from both sides. Okay, a little mental math here. 3 is 15 fifths. 15 fifths minus 6 fifths is 9 fifths. Okay, so putting together the pieces, y will be 1/5 x plus 9 fifths. Okay, all right. And then that second way was to use y minus y1 equals mx minus x1. All right, so then as before, we'll put in the slope, which was 1/5. And then we need to put in the x and y coordinates for one of the points. Just for fun, this time I'll use the other point, which is -4, 1. So let's do that. Okay, simplify, taking out that double negative. We're going to distribute to remove our parentheses. And then lastly, let's just add 1 to both sides. So we have 1/5 x plus, and then we had 4 fifths, right? So 1 is 5 fifths. 5 fifths plus 4 fifths is 9 fifths. Okay, and that will do it. Okay, so the purpose of these couple of examples was to find the equation of the line, given a little bit of information. We saw we could do it given a point and a slope, or even just given 2 points. If we're given 2 points, the first thing that we needed to do was calculate the slope. In the next couple of examples, we'll be doing story problems, but basically they're going to boil down to finding the equation of a line. So let's try this one. We're to find f of t, a function that converts t degrees Celsius to Fahrenheit. And then we're given a little information. 100 degrees Celsius is the same as 212 degrees Fahrenheit. And then 0 degrees Celsius is the same as 32 degrees Fahrenheit. So it might be helpful just to organize my information in a table. I need to pay attention to what's the x here and what's the y. Here our input is t, and that's degrees Celsius. So we're going to be turning degrees Celsius into degrees Fahrenheit. So let's copy over our points. 100 degrees Celsius is the same as 212 Fahrenheit, and 0 Celsius is 32 Fahrenheit. So then we're going to need to produce the slope. So let's think about that. Our input is degrees Celsius and our output is degrees Fahrenheit. So in this problem, the y's are like the degrees Fahrenheit and the x's are like the degrees Celsius. I just have to make sure to put the right one on top, right? So for the slope, we'll have the change in y over the change in x. So that'll be 212 minus 32. Divided by 100 minus 0. 212 minus 32 is 180. And then 100 minus 0 is 100. That's 18 tenths, or 9 fifths. Okay, so there's that for our slope. To put down our function, this time, luckily, we actually have our y-intercept, right? When our C is 0, our degrees Celsius is 0, our degrees Fahrenheit is 32. So we actually have that. I'm going to put down the pattern, though, just so we can see how it works out. Our slope was 9 fifths. We know when x is 0, we should have a y of 32. So 32 is 0 plus b. So 32 is our b. So f of t, then, is 9 fifths t plus 32. There is a formula that will turn degrees Celsius into degrees Fahrenheit. As an exercise for you, why don't you try to come up with the function that goes the other direction? That is one that is going to turn a temperature in degrees Fahrenheit into one in degrees Celsius. So I'll leave it to you to try that. Meanwhile, we'll go on to another example. Okay, this one is about copper mining. So here it says the amount of copper ore produced from a copper mine in Arizona is modeled by this function. So this one we're given the function, which is pretty nice. X is the number of years since 2005, and f of x is in thousands of tons. So the input is in years since 2005, and the output is in thousands of tons. So we're going to make a little graph of f. It doesn't have to be beautiful. We'll make a little graph of f. We want to know the slope of the graph, and then we'll also tell at what rate the amount of ore produced is changing. So let's just try for a little sketch. So on the horizontal axis, it will be years since 2005. And then on the vertical axis, thousands of tons. Okay, I'm going to start with the y-intercept of 200. So that will be 200,000 tons. And then we need one other point on the graph. So let's go with 1. 1's nice and easy. F of 1 will be 200 plus 32, or 232. Okay. We want the slope of the graph. The slope of the graph is 32. At what rate is the amount of ore produced changing? It's 32,000 tons per year. Notice that the units on the slope will always be the y units divided by the x units. Y units here were in thousands of tons, x units were in years since 2005. Okay, and then one other question, we want to know how much ore was produced in 2012. So here you want to be really careful about what the function is representing. The function represents the number of years since 2012, so you definitely don't want f of 2012, right? I think I said 2012. So this is the number of years since 2005. So 2012 is how many years past 2005? It's 7 years, right? So we actually need f of 7, okay? So that will be 200 plus 32 times 7. And that's 210 plus 14, 224, or 424. And that will be thousands of tons. Okay. All right, so then one more question. We want to know when were there more, there more than 650,000 tons produced. So this one, we're not going to substitute 650 into the function. We want to know what value of t, or what year will correspond to an output of 650. So the function was 200 plus 32x. And so we're going to work backward to find out the year. So let's do that. Okay, so subtracting 200 from both sides, we'll have 250 is our 32x. And then we need to divide. So we'll have 250 by 32, that will be our x. So let's calculate that and get an answer. So this works out to be 7.8125. And so that's our value for x, and that's the number of years since 2005. So we'll have 2005 plus 7.8125. So that will be 2012 and 4/5, right? All right. So you can figure out 4/5 of a year, and then work that out in months if you like. But that basically will do it. Okay, so I just realized there's a mistake in this one. So let me tell you what I was thinking and how wrong it was. So here I should have had 650 minus 200, and that should be 450, right? I got 250 somehow. I wasn't paying enough attention apparently. So the whole rest of it's wrong. And what tipped me off the fact that it was wrong is that I ended up with 2012. For us to have 650,000 tons, but in the prior problem we'd had 2012 that were 424,000 tons. So something was definitely up there, and it was just my arithmetic. So sorry about that. We'll fix it right now. Instead of 250, we should have 450 right here. Instead of 250 here, we should have 450 here. So we need 450 divided by 32, and that's 14, a little over 14, so 14.06. Okay. So let's just scratch all that. And we'll say 2005 plus 14. That's 2019, basically. All right, so sorry about the error there. Okay, so let's move on to our next question. So this one is about fish. Here it says a large koi pond is filled from a garden hose at the rate of 10 gallons per minute. Initially, the pond contains 300 gallons of water. We're to find a linear function, v of t, that models the volume in the pond at any time t. So we know it is a linear function, and so it should be mt plus b. I'm not saying mx plus b, I'm saying mt plus b, because they're just telling us, okay, it's at any time t. So they're using an independent variable of t. Okay, so that's it. We're told basically that the input is time in minutes, and then the volume is in gallons, right? So we're told that initially, that is when time is 0, the volume is going to be 300. So 300 will be m times 0 plus b. So that means that b has to be 300. So we have our y-intercept already. And so the next and last thing to do is just figure out what the slope is. Fortunately on this one, they have told us the slope. It's 10 gallons per minute. Remember that the slope units are always y units divided by x units, gallons per minute in this case, and we're told that it's 10 gallons per minute. So it's just 10t plus 300. Okay, so that's our formula. Okay, and then next it says if the pond has a capacity of 1,300 gallons, we want to know how long it will take to completely fill the pond. Okay, so you might have figured that out at a glance. If so, great. If not, we want to be able to go through the steps. We want to solve for the time that it will get to 1,300 gallons. So 13, wrote 13. So we're going to solve for t here. Okay, so then subtracting 300 from both sides, it looks like our t will be 100, and that's 100 what? 100 minutes or gallons? Okay, I know all of you said minutes, so that's good. So it'll take 100 minutes in order to fill this pond. Okay, all right, so that does it for that problem. We have one more, and then we're all finished with this. Okay, so this one, there's several pieces to it. So here it says the manager of a furniture factory, sorry, 1 second. The manager of a furniture factory finds that it costs $2,200 to produce 100 chairs in a day and $4,800 to produce 300 chairs in a day. And then assuming that this relationship is linear, which is all we're equipped to handle right now anyways, find a linear function c that models the cost of producing x chairs in one day. So we're going to have as input a number of chairs per day, which is itself a rate. That's kind of interesting. And the output is going to be a cost. So there's this relationship between the money and the chairs per day. And the input will be the number of chairs per day. The output will be the cost per day. All of this is on a per day basis. Okay, so let me compile the information we have. For 100 chairs in a day, it costs 2,200. And then 300 chairs in a day costs 4,800. Okay, so we're going to come up with this function, but we also, I can see that we're going to end up needing a graph. So let me start thinking about that also. Our input will be the number of chairs per day. Our output is going to be in dollars per day. So the horizontal is our X, our number of chairs. The vertical is our dollars. So I'm going to calculate the slope, but I need to not mess it up. So we'll have the change in the cost divided by the change in the number of chairs. I need to make sure to put the right one on top. So the change in cost will be 4,800 minus 2,200 divided by 300 minus 100. Okay, we're just calculating the slope. So then 4,800 minus 2,200 is 2,600. And down below, 300 minus 100 is 200. And then that's going to be 13. Units on that are going to be dollars per chair per day. Okay. Each additional chair per day that they desire to produce will cost an additional $13. Okay, so formula. So this one we don't have the y-intercept like we did in the prior example, but we do have points on the graph that we can use. You can use either of these. I would probably just use the one with the smaller numbers, frankly, but it's up to you. So we have y equals mx plus b is the format I'm going to try to fill out. And so our output is 2,200. The slope was 13, our x is 100, and then we'll use that to help us solve for b. So 2,200 is 1,300 plus b. So then what does our b have to be? 2,200 minus 1,300 is 900. Okay, so that will be our y-intercept. So then our c of x will be 13x plus 900. Okay, let's take a look at that, make sure that it makes sense to you. All right, so let's see what the graph of this is going to look like. So the y-intercept is at 0, 900. So this says that our costs would be $900 to make no chairs per day. If that seems silly, like how could it cost something to make chairs, keep in mind that this would be what are called fixed costs, the cost just to keep the doors open, right? Pay for your lease or your insurance or the electric bill or something, right? And then from here, it just goes up in terms of how many chairs are produced. Okay, so we can just put one other point on the graph, something like 100, 2,200 would be sufficient. Okay, and then here it says we want the slope. We determined already that the slope was 13. And then it says at what rate does the factory's cost increase for each additional chair produced? So we'd answered that already. It was $13 per chair per day. Okay, so that takes us to the end of this example and the end of this video. Let me know if you have any questions, and have a great day.